everybody. Here we are, 6.4 functions. So to start, what is a function? I will type it out. It's a relation. It's a special kind of relation in which each value of the independent variable is associated with exactly one value value of the dependent variable. And let me make that a little bit bigger. And yeah, as I said, it's a special kind of relation. So here's a thing is that all functions are relations, but not all relations are functions. Just as, all squares are rectangles, but not all rectangles are squares. Just as all, thumbs are fingers. Wow, look at that! Look at that beautiful hand. But not all fingers are thumbs. All bananas are fruit, but not all fruit are bananas, etc., etc., etc. So that is a little bit about functions to start. And one of the ways that we can tell if a relation is a function is through the vertical line test. So often this is done. I think I did this in my Math 10 class with a pencil. So for each pair of relations, decide which relation is a function and which is not a function. So the vertical line test, there's a few different ways you can do it. You can drop a line down through a function, and if it only cuts through it or crosses through it at one point, then it's a function. So if we dropped, so this is, yes, a function. But if we drop a vertical line down through this relation, it cuts through the relation at 2 points. So, there and there, there and there. This is not a function. Because this means for a given x output, there's 2 y outputs. And we need, for every x, we need for there to only be 1 y. And the pencil test that I mentioned that I would have done when I was your age is if you put your pencil along the function. Like that. There's a lead. And if you roll it sideways, if it only kind of touches the line ever at one spot at a time, then yes, a function. But if we were to roll the same pencil sideways across this one, it would touch at the same time, this dot and this dot, this dot and this dot, and all of these ones. So that means for each x input, there's more than one y. And so this is not a function. Okay. The next part of the lesson is about function notation. And function notation is just a kind of different way of representing a function. It's, let me say, it highlights the input/output nature or aspect of the function. So it highlights that for every one input to x, there's only one output into y. And that's, remember, specifically what a function is. So it kind of highlights that aspect of a function. And it can be helpful later if you kind of have like inception functions and you have something like function of x is function of g, something like that. It shows that you kind of solve the innermost function first. So it can be helpful later on. But this is essentially saying, and it's also kind of a shortcut. So, we might be used to seeing this as y equals 3x plus 7. And if we want to know, what is y when x equals -2, you can write it out like that. Or you can simply write like this: f of -2 equals 3x plus 7. And then we know specifically, we are asking what is y, or what is f of x when x equals -2. So we're just going to input this into our x and solve. So we're looking for 3 bracket -2 plus 7. We scroll. Remember, our bed mass, 3 times -2 is -6 plus 7 equals 1. And so f of -2 equals 1. Let's do the next one. We're going to use the same equation. We're just going to input our 1/3 in for the x. So 3 bracket 1/3 plus 7. 3 times 1/3 was 1/3 of 3. 3 over 3 is 1 plus 7. That equals 8. So f 1/3 equals 8. And our last one's kind of the reverse. What is x if f of x equals 34? So we're looking for, now we have f of x, we have 34, equals 3x plus 7. And now we're solving for the x. So let's use kind of classic algebra. Let's get the x by itself. Let's start by subtracting 7 from each side. We get 27 equals 3x. Let me scroll a little bit. Let's divide by 3 on each side, and we get x equals 27 divided by 3. That cancels that out. 27 divided by 3 is 9. We circle those answers. Okay, and let's move on. Make a table of values and graph each function. So we're going to be solving a number of f of x's. Let's make a table of values. We've got x on one side, and our f of x is on the other side. And let's do it. So first one, we input -2 in for the x. 2 times -2 subtract 7. That's -4 subtract 7. So when x is -2, f of x is -11. If we input the next one, -1 times 2 is -2. -2 subtract 7 is -9. So -1, that's -9. And then you can see a bit of a pattern, but let's do it. If we input 0, 0 subtract 7 is -7. And then I think we can kind of get it from here. 1, 2, 3, 4. We're going up -5, -3. We're just adding 2 each time. -1 and +1. And now let's make our graph. So we got a -2, -11, -2, -11, all the way down there. Next, we have a -1, -9, -9. Next, we have 0, -7, 1, -5, and then you can kind of see we got a 2, -3, 3, -1, and a 4, +1. And there we go. let's do our next one. Oh, by the way, function might not always be f of x. It could be g of x. You might see a of r for area often. So it can be letters other than f. And this is asking for the domain. So this is suggesting, as well, that we need to input these values in for our x. Let's make another table of values. Got x, got g of x, and we want a -9, -6, -3, 0, 3, 6, 9. They've given us beautiful numbers to put in here. Look at, we have 1/3 times -9 plus 1. A third of -9 equals -3 plus 1, which is -2. The next one, if we input -6 in there, a third of -6. And there is, maybe I'm doing this a little quickly because I can do that in my head, but I should show you 1/3. It's saying times -6, which is like -6 over 1. Multiply the tops, you get -6 over 3. -6 divided by 3 equals -2. And -2 plus 1 equals -1. And our next one, if we input -3, a third of -3 is -1. -1 plus 1 is, -1 plus 1 is 0. And now it just looks like we're going up by 1 each time. Looks like we're going +1, +1. So I'm going to say this is 1, 2, 3, 4. Looks like that makes sense. If we input 0 in for x, g of x equals 1. And now let's plot it. We have our -9. Wait, is that negative? -1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's right. -2. We have -6, -1. -3, 0. We have 0, 1. We've got 3, 2. We've got 6, 3. And we've got 9, 4. So there you go. I'll let you know which textbook questions I'd like you to do. Thank you so much.